So let's take an example of a particular string and a particular pattern. I'm taking the pattern as AB, ABD. If I want to create a pi table of this, the pi table of this would be created in this way, that we have got AB, AB, and let's say this is T. This is the index for a pattern. We are starting with 0. Why? Because we have to compare some values. A cannot be compared with anything, so we have taken it as a reference with 0. So A cannot be compared, so by default its value would be 0 as well. B is compared with A, don't match, 0. A is compared with A, match, 0. Your pointer is moved. B is compared with B, answer is 2. A is compared with Z, answer is 0. So this is what a pi table of a pattern would be. Let's talk about the string. So I'm taking a string as, I'll definitely take the string as a repeated sequence would be A, B, A, B, C, A, B, C, A, B, A, B, A, B, D. Let's say I'll take this string. Now I'm going to match, just check one thing. Your initial pointer is J at 0. So your pointer will shift accordingly. You are going to match with S of I is at this location, A with pattern of J plus 1. If initially the pointer is at this particular instant, P of J plus 1 would be this A. It means P of J, there is no value which is there, but P of J plus 1 would be your A. So your A is matched with this A. Definitely there is match. So what you will do, you move your pointer I. So I points over here and your J points here, right? Obviously, you are going to match with S of I, which is now B with P of J plus 1 and J plus 1, J is pointing towards A, but J plus 1 answer is J plus 1 points to B. So J plus 1 becomes B also. So it means you will increment I and increment J pointer locations as well. So I comes over here and J comes over here. Then again, you are going to check S of I, which is A, is compared with P of J plus 1. Earlier, P of J plus 1 was B. Now it is A. A is matched with this. Obviously, there is a match. Then this will be a match, right? Now your I will point over here and your J will point over here, right? Now, I will be checking that S of I, let me just check the value of S of I. S of I is C and P of J plus 1. J is actually pointing at this location only. So P of J plus 1 actually is D. So there is no match. When there is no match, you will move J to the index mentioned in pi table. So J is actually over here. So what is the index mentioned on pi table? This is 2. It means J should move to 2th location. Over here, I am removing these values. So since J was pointing at 2, right? So you are asking J to move to the index mentioned in pi table. So again, if I have to see where the index is, this is, let's say if this is 1, this is 2, this is 3, this is 4, this is 5 index. So you are moving J to index. So over here, now J points over here. Fine. So this is what the algorithm that is providing us the instruction. Earlier J was at this. Now your J comes over here. This is your J, right? So I'm talking about the indexes. This is the indexes 1, 2, 3, 4, 5, considering J index started with 0, right? Now If j cannot move, then move I. Obviously, I will be checking this again. S of I again is stuck at C of I, that is C only. That is S of I is still C, is going to be matched with P of j plus 1. So j was pointing towards B. J plus 1 becomes A because this is what we are matching. I'm matching this A with this A. Is it matching? No matching. It means move j to the index mentioned in pi table. It means clearly you have to move this j to the index mentioned in pi table. Index mentioned is 0, so you are moving j to 0, so j comes over here, right? Now again, we are going to check S of I is compared with P of j plus 1. So j is pointing towards 0 index. So j plus 1 becomes, this is 0, so there is nothing. P of j is actually no value, but P of j plus 1 becomes your A. So I'm going to check this over here, this matching with C. Unfortunately, this is no match. And even if I move j to the index mentioned in pi table, which is 0, it cannot move further. When it cannot move further, it means in that scenario, if j cannot move further, then move I. So it means nothing will match this whole scenario. So I would rather move my I from C to this over here. So S of I has now become A. Now, j is 0 location, it is there. So p plus p is equal to, we have to just check S of I, which is now at A. We have to check p of j plus 1. So j is pointing to 0 location, but j plus 1 becomes this over here. This answer is A. A and A are matching finally. When they match, you have to move the j. So earlier j was at 0, now j is at this location. I comes over here because it is a matching, so I comes over here. Again, we have to check S of I. S of I is now at B. We have to point j plus 1. Your j plus 1 would be this value. So this value would be B also. I would say that we will increment I and increment j. So now j points over here, right? Then we have to again check this whole part. Now your I is at this location and j is pointing towards B. So we have to get the values again. Your S of I is C. P of j plus 1. J was B. J plus 1 would be A. Again, there is no match. When there is no match, so it means you have to move this j to the index mentioned in pi table. The index mentioned is 0. So it means move this j over here. Now j is at 0, guys. Again, you are going to check. Again, you are going to check whether C S of I, which is C, can be matched with P of j plus 1. Again, P of j, if it is 0, so P of j plus 1 becomes this A. Whether C is equal to A, it cannot move further. J cannot move further because it is already at 0. It cannot move further. Then again, what we will do is we will move our I. So I would be moving from this C and I should go to this A. Fine. Now your entire scenario, I am going to create the entire scenario over here with this scenario. Just a minute. We have got A, B, A, B, D, 0, 0, 1, 2, 0. Your J actually is at 0 location. Again, we are going to check S of I, which is A, P of J plus 1. So earlier J was at 0, so J plus 1 would be 1, 2, 3, 4, 5. P of J plus 1 would be P of 1. It means it would be P of 1. Its answer is A. A and this A matches. So I will move my index of J. So J comes over here. Then I am going to check this I, right? And we have to check with J plus 1. Earlier J plus 1 was A. Now J plus 1 would be B. B and B are matching. This B and this B are matching. Then this A and this A are matching. This B and this B are matching. Then unfortunately this A over here, I comes over here and J comes over here. Till there we have this whole scenario lined up. So I am basically putting my J over here. Guys, just check. Your J comes over here. And your I comes over here as well. So in this particular scenario, what happens? Your S of I, which is A, and P of J plus 1, which is D, they don't match. In that scenario, you have to move J to the index mentioned in pi table 4, 5. So it is given as 2. So it means you have to move J to 2. So J comes over here. Now I am, see, these are the indexes of J. So indexes of J can be written in this way as well. This is 1, this is 2, this is 3, this is 4, and this is 5. Now you have, since J value did not match, so by default, J should point to the index mentioned in pi table. So index mentioned was 2. Now J has pointed over here, right? Fine. Then again, in this case, we have to check the values again, whether there is match or no match. So if we try to see this particular scenario, your S of I is actually I, and P of J plus 1 we have to calculate. It was A only. So P of J was pointing towards B. P of J plus 1 would point towards A. So this A and this A matches. This B and this B are matching. D and D are matching. It means this is present. If you notice one thing, they have by default saved the prefix AB. Then we matched ABD. So this is what your KMP algorithm is all about. You have to move J to the index mentioned in pi table only if there is unmatch. Now, in this case, over here, instead of starting the same process from A, then B, then A, then B, then D, we started the process with ABD, considering saving AB was already saved. This is known as your KMP algorithm. And if I want to calculate the complexity of this algorithm, the complexity would be, first thing is, we created a pi table, and pi table creation is entirely dependent upon your pattern length, and pattern length actually was your M. And second important part was that after creating the pi table, then the matching was done. Matching was entirely dependent upon your string length. because we process each and every character of string. Let's say if we were writing ABC, ABC, AB, AB, ABD. So we process from this A to this D. So technically, it took how much? It took the length of the string only. So the complexity would be order of n plus m, because this was a separate loop and this was a separate loop when it comes with matching part. Hence, the complexity would be order of n plus 1, which is always better than the previous complexities calculated for string matching algorithm. Thank you. If you like this video, kindly like, share, and subscribe. Share it to maximum audience. Thank you for all the support.